Here we go. Good evening, everybody, and welcome to Josie Jug. Some of our attendees are from different places in the world. Josie is what Johannesburgers call our hometown, and we don't need to go into why it's called Josie Jug. Jug is started as the Java user group, but now we actually call ourselves just the JVM user group because we support other languages that exist in the JVM world, like Groovy and Kotlin and sometimes even Scala. But that we just mention in anger when we complain about it. So welcome everybody. We've got some guests from abroad. Our speaker is Gerrit Meier from Germany, works for Neo4j. And I'm going to hand the reins over to him. And he is going to be our host for the rest of the evening.
Yes, thanks for the invite. I already got just a second. This computer work it will be inception. So yes, as I said, thanks for the invite. I hope you can see the screen. If you have any questions, comments, you cannot read anything, you did not understand anything. The last number I've seen were 12 attendees, so just unmute yourself and ask a question. I cannot see the chat because everything is in full screen now. But there's also Michael Simons, my colleague, in the chat, so you can ask text questions to him, and I hope you will have fun. When I got invited, I was really happy to speak about our current project, Spring Data Neo4j UX. But Colonel asked me to give a little bit more introduction what graph databases and Neo4j is. So I hope, yeah, some of you enjoy the lunch or the dinner or already had dinner, because it's gonna take a while maybe today. So let's start with our rough agenda. First, a short introduction what graph databases and Neo4j in particular are, how we can use them, or you can use them. Then we have a short excerpt to our query language, so-called Cypher. And then we come to, for me at least, the most interesting parts about the higher abstraction levels. That is what we are working on, the so-called Neo4j OGM, the Object Graph Mapper, and on top of this, Spring Data Neo4j, and our current project, Spring Data Neo4j UX. You can be happy today because you will hear brand new news, some things we decided over the last weeks and final decision made today. So I will give you more details later on this. So what are graph databases? I don't know who of you are aware what graph databases are. Normally with an audience, I would ask, raise your hands, but I cannot see anybody. So graph databases, in the terms how Neo4j is structured, are labeled property graphs. So basically they consist of two things, cycles and lines. And in Neo4j, we will have a directed labeled property graph. So the lines have little arrows on it. That's basically what we call a node and a relationship. To make it more labeled, and later we see the property labeled graph, we can put on labels on nodes. In this example, you can see just one label, but it's possible to have multiple ones. A relationship will always be of one type, so you do not have the chance to have multiple kinds of the same, very same relationships there. But there's really no need to have this, just to see it. So to come to the property part of a label property graph, you can store information on either nodes or the relationships. So for example, our node or circle is now a person. And the person has some properties like a name or a date of birth. Also, on the relationship, we can store information like we do on the node. A person knows a person who she or he met at, for example, this Java user group today. So even if it looks like JSON, it isn't JSON. So be aware of this. It just looks like JSON. Then we can spin up a graph of this. So we can say we take our circles, or a few of them, and a few lines with arrows on it. So a person knows a person, and both are interested in a certain topic. For example, Spring Data. If you are not today interested in Spring Data, you are at least interested in graph databases and Neo4j. That's also cool. It looks like this graph is the representation of our team. That's my colleague Michael. You have him in the chat, and me. So Michael works now almost, I think over 2 years with me in the Spring Data, Neo4j and Neo4j OGM team.
Actually, tomorrow is our 2-year anniversary, dear Gerrit.
Tomorrow or today?
Tomorrow, exactly.
Tomorrow, okay. So, of course, I knew this, but I just wanted to hear if your mic is working. If you want to reach out to us, to have any questions, and want to ping us personally, the best way is on Twitter. So either Meister Meier or Wattenroll666 for Michael. So what is Neo4j? First, a buzzword slide. Neo4j is the #1 platform for connected data. So even this is a marketing slide. I like this slide because it promotes the importance of connected data we are working with in our day-to-day lives. And the data we are working with, it gets more and more connected. So that's also a reason why we say we value relationships, either in person or with the data you're storing in Neo4j. So like you see in the examples underneath, there are certain fields where Neo4j gets used, be it fraud detection or recommendation engines or similar cases. But in general, Neo4j grows to a more general purpose database, but also has the power for graph analytics, graph algorithms. So you can analyze your data even better with this nature of this graph than you would, for example, have to in a relational database. For me, this is quite interesting, the point, because when I started in Neo4j, I heard of Neo4j, I heard of graphs, but I always thought that tables are the only tools of data storage. But the difference between just data storage, so you put data in, you read data out, and the graph database where you put data in, but you can then ask the database to give you more information, insights of your data, gets more important with the amount of data you store. So, of course, I know that in relational databases is also possible, but some of us learned it in university, the whole graph algorithms, etc. But now you can really apply that in your day-to-day job. If you never heard of Neo4j and you barely knew what the graph databases, you at least heard of these headlines. They are quite old right now. When I put them first into the slides, they're what was it? The Paradise Papers were pretty new. And it makes an impact to have this power of analytics. So I can tell you it's good for analyze your relationships within your stored data. But as you can see, it also makes a change when you want to pass this data. For example, the ICIJ did not know what to do with all the data. They wanted to have it at hand. They want to analyze it. They want to find relationships, and not only these directed relationships, but patterns in the graph. And so Neo4j got their first choice then. So if you want to do something like a pen and paper analysis or similar, the first thing you want to have is a Neo4j instance. So to get started, we have several ways of doing this. For once, you can just grab the binaries of the pure server. I just call it now pure server because there's so many differences. Or use, for example, our Docker images to just spin up an instance and have it running on your local machine or your home server whatsoever. To stay in your local network, we have also a desktop version. So you get a Neo4j desktop client that makes you capable of managing multiple instances at once, your projects, etc. That's one thing. The other thing is that Neo4j supports plugin, and you can drop the plugins in your pure server installation, but in the desktop version, you can, for example, visit the Graph App Store. It's not really a store. You do not have to buy it, but you can click your plugins there to give more power to your desktop version. So what I mean with plugins, we will see in a bit. Or you can just say, I opt in for a hosted instance. So we have our very own cloud offering right now. It's called Aura. So you can just click your instance of a Neo4j server and let it get hosted by us. There are other ways to have a hosted instance like Google Cloud Platform, Azure, or AWS, where Neo4j instances are available in their very own marketplaces. So we take care about providing them, but since I know that somebody from Azure is there, but it takes some time until the versions get there. Let's call it so. So I mentioned these plugins, for example, in the desktop versions. Neo4j is not anymore just a database. It's a whole ecosystem. And it's an ecosystem that is, on one hand, powered by the whole community, and on the other hand, by our internal development. So for example, if you strive for visualization, we provide you, when you install, if you install a server with a Neo4j browser out of the box. So you can just, after you install the database, see the data or put in data over the web browser console. In the Neo4j desktop, you have the ability to use Blue. That's a more, I would call it browser on steroid, more advanced browser. So you can also manipulate data, do selective research in your graph, and also apply queries baked by Cypher. see it later, but written in a natural language. So a cipher engineer, developer can put in valid cipher statements with placeholders, and then can then refer to the placeholder in a natural sentence generator. So a business analyst, for example, does not want to write cipher, but she or he can enter this natural language and query the data, and then explore the data that gets returned from the database. So, but there are tons of community or other companies who provide visualization for Neo4j, like NeoVis, the D3 library in JavaScript, or with JavaScript, or then really bigger companies like Linkurious, who support the connection to a Neo4j database. So, and then render your data. Then a really new kit in Neo4j, in the Neo4j ecosystem, is the Graph Data Science Library. The Graph Data Science Library gives you algorithms for community detection, centrality, similarity, then a little bit more advanced heuristic link prediction, and the pathfinding algorithms. So if you want to really analyze the data, you apply algorithms, but do not want to write them on your own, you are good with going to the GDS. Driven by Neo4j, but also with a lot of contribution from the community, plugin is APOC. So this awesome procedures on Cypher. It could also be seen like APOC, the guy from Matrix who got killed by Cypher. But we do not want to have any trademarks and fragments here. These both are really good for data science. But beside data science, APOC also provides you with utilities like loading data from a JSON URL, from a CSV file, and from a JDBC connected table or relation database. So if you want to try out Neo4j with your existing data that is stored in a relational database, you can just connect it to an APOC procedure and then load the data with some mapping hints into Neo4j. Another interesting approach for the people who do not like property graphs, but more RDF, is Neosemantics. Neosemantics is also pretty new, but it tries to put RDF compatible information or access on top of Neo4j. And for the users with high throughput, we also support Kafka streams. Kafka streams. And as I already said, you can find more in the app gallery in the desktop, Neo4j desktop client. But having now this full-fledged Neo4j instance running, you want to do something with it. So the best way is to connect to your database. There are several ways how you can interact with a Neo4j instance. This is my top tier list, where best and bad are very close together. So if you run Neo4j in server mode, you will have the bolt protocol enabled per default. This binary protocol is the de facto standard when we are working with the database, because it gives us a lot of information about the data that is in there, with type informations, etc. So bolt protocol is the way to go, but yeah, you do not want to write your binary protocol connector. For this, we have drivers. You see this in a bit. But if you have no restrictions, opt in for the bold protocol. The HTTP connector is the first connector that were available for Neo4j. It has the benefits of you do not have to use driver for this. You can make this calls by hand. And it works maybe a little bit nicer with your company's firewall restrictions. But the reason why I mentioned this explicitly in bold for the data types is that HTTP is a little bit lossy. So you get the data back, but for example, you get a number back and you do not know if this number should be a double or float or whatsoever. And the third option is running a Neo4j instance within your JVM. So you have a running application and it starts up the Neo4j instance. So this would be the, I did not even mention it in the one modes. It would be another one mode to pull Neo4j as a library and start it within. So they will happily share the memory. They will happily share garbage collection as a result, and they will happily share crashes. So I would say it's so bold. Neo4j never crashes, but if your application crashes, Neo4j also crashes, and Neo4j crashes then very unexpected. So I wouldn't advise to use an embedded Neo4j instance if your use case allows the other connection modes. So as I mentioned, the drivers to connect to the bold protocol. So there are we have drivers for for 5 languages. I won't say major, but it's Java in there. So Java, Python, JavaScript, C# and Go, where I don't know if anybody had experience with the former Go driver. The Go driver we have just released is the real Go driver now, because people complained about the C dependency in there. So it got completely rewritten by the by the driver team, and can be used now completely C-free if you do not want to link anything in there. There are also a lot of community drivers out there. I just picked a few. For example, R, especially useful for people making graph analytics, data analysis, etc. The Rust driver, a more basic, let's call it a basic one. This works good on bare metal as a binary. It has all the safetiness of Rust without the dangerous experience of C. We have an Elixir driver, so an Erlang Elixir driver, and Ruby drivers out there. There are also drivers for Perl, PHP, and similar. These are more or less actively developed by our community. And one interesting thing is the JDBC connector. So you can speak with a Neo4j instance over bold, but your application connects via JDBC. So there's this kind of driver middleware you can use to make use of this. That's at least interesting. And having these drivers at hand, you can then query the database. The query in the database, the most basic for us is Cypher. That's our, I've written this. Cypher query language is to Neo4j what SQL is for relational databases. I do not want to go this far and say it's is to graph databases, what SQL is for relational databases. But we open source Cypher. So 99% of Cypher is open source, or at least not connected to Neo4j. So this is general purpose query language then. And there are efforts to make parts of Cypher the de facto standard for querying graph databases. So let's see what we can do with Cypher. So I hope you remember this graph. We drawed this graph a few slides ago. We have two persons where one person knows another person and both are interested in the same topic. And with this, we want to populate the database. So one easy step would be create person. I just named them now because we need this later. We name them, we just name them, we do not put properties on them. I will tell you in a bit how this will look like. So this statement will create person node, for example. But we want to create more. We want to create connected data. So I say a person node I will create is interested in a topic. And I can also, just a second, I cannot see what you see because, okay, I try my best. And now we have the second person also connected within the very same query. We just comma separated the queries. But the interesting bit you can see in the Cypher statement is that we can reuse named nodes. We could also reuse, it makes no sense. Okay, we can reuse named nodes like the topic. So the first person is interested in a new topic, then named topic, and the other person should get interested in the same topic, in the very same topic. So we just refer to the name of the first node, and then we can be sure that there will not two topic nodes be created, but only this one. But yeah, we are missing out the nodes relationship, so we just add this here at the very end, and we use again the named nodes to create a new relationship between both of them. So now we have the data in the graph, and everything is looking fine, but we also want to query the data. So I tried to also symbolize this with a picture in the top right corner. What you would see when you return the data. So for example, we can, for a match that returns the match that selects the nodes before it returns, we can use the very same syntax. So we have this ASCII art style syntax all over the place, where we say we want to match a person who's interested in another topic, and the return might be not so intuitive, but will be two persons who are interested in the very same topic. And for the correctness, I missed to return the relationship, so you won't see the arrows. But right now we should just skip over this. Do I want just a second? Persons who are interested in a topic. Okay, that's the more verbose way of doing this. So we again select the. Okay, yeah, that's a more verbose way. But now we should get both persons returned. So a person who is interested in the topic and another person who is interested in the topic is the other person. So the selection could be either starting with the first one is top left corner or the top right corner. So in this case, this is ambitious if person is the first one or second one, but we will clarify this with the next query, because we then say the person knows, and then now this direction comes in play, the other person. Maybe the other person doesn't know the person. And we can then say, hey, if you know this, you know a person who's also interested in the same topic like you are. That's my poor man recommendation engine to do this. But then we played with the data and we want to delete the data. So we do this in the same way like we query for data or select the data. We first want to reach out to the database and say, hey, I'm interested in this nodes and relationships, and please then delete it. So I could go there and say match person, but that would hit both persons again, and then say delete. If I do this, I get a problem because I cannot delete connected nodes. So we value relationships so much that you cannot delete related nodes or entities. So you have to first either get all the data that is in there, like we do with this query. Again, I use the named ones, so we select persons who are interested in the topic. And to be sure that we, do I have a pointer here? No. To be sure that we either way hit the other person when we want to delete it, we make the query now undirected for the nodes relationship. In the queries before, we did this error all the time in one direction. In this direction, we do not care about the error. So this gives us the possibility to do a more broader query. So it selects both ends of the query. And then I can say, please delete person I and K, because the person would be, okay, I could add other persons to be more explicit here. But as I said, when I do not care about the direction, the person might be, the person I match with the first line might be both persons. So I get two result rows, and then I can say, please delete everything. That's for Cypher. That was the easy part with Cypher. If you want to call procedures, etc., there are tons of documentation on our side. That does not mean a ton that you do not want to read. You want to read it. So every procedure call looks a little bit different because we use namespacing and similar. So I did not want to add this also to this talk today. It can get a lot of information then. So I go to the topic that I like a lot and come to object mapping. So writing Cypher makes fun. Writing more Cypher gives you great results. But there are certain situations where you do not want to write Cypher with your hand all the time. You may opt in for custom Cypher at some place. We will see this. But we see a lot of customers who really want to just store their data and retrieve the data. That would be the easiest bit. Of course, you can call graph analytics within, etc. But we concentrate now on storing and retrieving data with object graph mappers. In the agenda, you have seen that there are, that I mentioned, 3 ones. The two ones we will see now are close together. This is Neo4j object graph mapper and Spring Data Neo4j. And the third one, Spring Data Neo4j RX, is a complete new development. But you should keep in mind that everything I say about OGM, like annotations, how it works, how it gets configured, is more or less applicable also to Spring Data Neo4j. So what is Neo4j OGM? Or where does it live? As I mentioned in the connectivity part, we have three transport modes or connection models. You can use embedded, bold, or HTTP. We support in Neo4j OGM all three connection modes, where we rely for both on the Java driver. This makes OGM very compatible with your environment it's running in, but also gives some limitations, like general functionality that we have in the bold protocol. For example, explicit type informations. So for this, we may have about the amount of information with the embedded API, but on the HTTP protocol, we do not know and have to make a best guess on the data that gets returned. That's one limitation we will see there. But in general, it works with all connection modes. So OGM is made of a set of annotations that you use to describe your data. We see this in a bit. For configuration, that means with OGM, you can also configure your driver connection. So you do not have to even know about everything that this is a driver if you do not want to go with the more detailed property to the driver. And in return, it gives you what I call a basic data access. So we have domain methods. That is something I call that you can say for your domain like a person. We had the example, you can store, update, read, and delete the data. So the basic CRUD operations. But you can also go to the so-called OGM session that we'll see in a bit, and call it custom cipher queries. So you can formulate your own cipher and then say, please map this cipher to a, for example, person or person class. But basically the heavy lifting of all the mapping, so which node looks like a person and how to get the information on this node to a person instance in my Java world, or vice versa, is done by OGM. That's pretty cool because you provide the information and we do our best with the information to map the data back, forth and back. So a pretty simple example is this class. It's also a little bit more verbose than you would need it for this class, kind of class. But I just wanted to give you an idea how this looks like. So you have node entities. You can then say, oh, the node entity will be derived from the class name if I do not define anything. So it would be person entity, but I have persons in my graph. I want to have to store it and retrieve it as a person. So we can say the label of this class is person. Then we support different strategies for ID generation or no generation at all. If you would set the ID by hand, but in this case we use the Neo4j internal ID. So we store an object with a null ID, and after the storage in the database, after the store call in the database, it comes back to us, it returns us the ID, and we apply the ID to the entity. The property, yeah, I just call it in Java world. You maybe know some of those DBAs who say, no, I want to have this and exactly this name for this very property in the graph or in the database, but you do not want to work with this property in your Java world. So you have this property name mapping. You do not have to annotate all properties with at property if you do not want to rename them. But in this example, for the full name, I did this. So a full name in Java world will get stored as name in the Neo4j world. And then for brevity, I just added one relationship. So we have the nose relationship to the other person that you have seen. So there are also ways to define relationships with properties in OGM, but yeah, given the time, we just skip over this, and we have a very good reference manual for this. So as you've seen in the introduction, all the slides before, we have one type you can define for a relationship. This is now our nose relationship, and the default direction is outgoing. Here we define it explicitly. So you can also model your domain for incoming relationships. And just a second. Besides that, Neo4j internally always uses directed relationship. We leverage this to undirected relationships. So in on your application level, you can define undirected relationships that are under the hood in the database are directed. But you lose those informations. But you would have, for example, in those relationship, the advantage that even if you load the other person, it will have a connection to the first person. So there are use cases where it makes sense to have this. This is more or less the foundation. All the magic happens under the hood of mapping, etc. For object graph mapping, as it is right now with Neo4j OGM. And to combine the demos I just go further to Spring Data Neo4j, so we can see the demo and how it works together with both projects. So what is Spring Data for Neo4j? Of course, by its name, it's a Spring project. It's a Spring Data project. It depends on the Spring framework. So if you are using or creating a Spring application and want to work with Neo4j, and you want to have this object mapping facilities, you should opt in for Spring Data Neo4j. It helps you more than just the simple quad operations of Neo4j OGM to abstract from Cypher. If you want this, you can still use custom queries, but there are a lot of functionality in there that makes you just want to define a method. For example, we see this in the example, and do not work with this. So these methods are derived query methods. So by the name of a method, we generate a Cypher statement for you and query the database. And if you have worked with another Spring Data module before, Spring Data Neo4j also feels like using a Spring Data module, one of the others. And you do not have to learn or relearn concepts. Yeah, as I said, we have this quad support out of the box. It's worth to mention that it's much broader than what Neo4j OGM provides, and it should be called quad on steroids. And with Spring Data Neo4j, as it is right now, we are aware of graph operations. I always like to mention this. If you query for data, be it in Neo4j OGM or Spring Data Neo4j, there is a virtual limit of your depth. You are loading the data. You're persisting the data throughout your whole Java object graph, but loading the data is limited. And if you want to manipulate this horizon of loading your data, you can do this directly in the either in the quad methods. So we overloaded the quad methods to accept I call it the second parameter for the horizon, but you can also define it in this derived query methods. So you can always load the data you need and not fetch the whole graph in this case. If it makes sense for you, that's something you have to decide. But something you have to be aware of, that you do not load the whole graph when you call a find method or similar in Spring Data Neo4j. So SDN, Spring Data for Neo4j, is currently in version 5.3 out there. It's bundled with the Neumann release train of Spring Data. And it's also available as a Spring Boot auto starter, the latest version in Spring Boot 2.3. It supports a schema-based loading. Before version 5, we had path loading. Now we do not load too much data, but only the data that is needed. So, or at least all the nodes that are needed and all the relationships that are needed. And it provides persistence constructor. So if you come from the JPA world, you always have to use this empty default constructor and immutable mapping. But this is a little bit limited because OGM under the hood first loads all the data and then tries to map it. That can lead to circuits in your graph, so it cannot set any property anymore or similar. So I would call it limited immutable support. If you already work with Spring and, for example, use the Spring expression language, you can also use it when you define your custom cipher statements in Spring Data Neo4j. And now's the time for demo. So hoping for the best that this works, and I hope you can see my screen. Yeah, no negative feedback is good feedback, I think, yeah. So the example project I've created for the SDN OGM part is based on the latest Spring Boot version and pulls in the Spring Boot auto starter for Neo4j. This starter then puts in the latest Spring Data Neo4j version, of course, and the Neo4j OGM version. So we have everything at hand here. That's just my tool set I want to have to show you how this could look like. Because I have a much more important thing to announce, we will skip over the typing bit, and I excuse for the loudness of my keyboard. I haven't thought about this. Yeah, you will hear me typing. So it's, as you can see, I hope some of you are familiar with Spring Boot applications. This is a more or less standard Spring Boot application. I just added the command line when I interface that I have something that I can run when the application starts to bootstrap some data and show you some examples on this. But I just wanted to have a setup where we do not have to configure anything. So I just copy my code. In there, and this is the OGM example we have now. So first of all, for OGM to work, and I said we have this configuration that gets passed to the driver, we have to configure the instance. So we say, I want to connect to this to this host with those credentials. Okay. Then we pass over this configuration to the session factory. The session factory expects as a second parameter the package where it should, or the start package that it should start scanning. So for now, I just have the person in there. In this example, we scan the person package. So it will hopefully find an entity that is in there defined. And then we do for our operations, open a session. And this open session is something you have to keep in mind when you do this explicitly, because a newly created session will have a fresh cache, session cache, and use its very own transaction. So you cannot have two sessions in the same transaction or similar. But this set, we look to our domain model, how it looks like. So it pretty much looks like the model we have seen before. Because I wanted to do a short introduction on all the quad methods, I created this empty constructor for loading, because I do not explain the home model with my constructor here. But you get the idea. We have this node entity defined to person, and we have the a name for the person and other persons who knows this persons. So we can then say should opt out for the ID. So I have a person called Gerrit. I have a person, and I say I hope that every, oh, that's the wrong browser. This one. We have here the Neo4j browser, and it should be empty because it is not yet started. So it will be pretty empty. As I said, you can use Docker if you, and do not mount any volume, so you lose all your data all the time. But it's an easy way to just play with a Neo4j instance and use it for examples. And in the meantime, while this instance, oh, it started, I just end my sentence. There's a, speaking about Docker and Neo4j, there's a good integrity with test containers in Neo4j. So there's a Neo4j package for test containers if you want to start your containers within your Java application or your Java tests, integration tests. You could check this out. I do not have this on the slide, but it just came to my mind to announce this. So back to example. as you see, there are no data in the database. Yeah, I do not want to output data. I just want to store those data and connect Gerrit to Michael. And if I start this application, you can see the most simple example I can come with running with OGM. I do not know if I have, no, sorry, I don't have debug logging on, so you won't see this. But then I can just rerun my query. Look at the graph and you can see that Michael knows Gerrit. That's pretty cool, but having a Spring Boot application at hand, Spring Data Neo4j, we can use another abstraction level. So Spring Data Neo4j does not have a lot of, as it is right now, a lot of abstraction layers, but repositories. So we can use the very nature of Spring Boot that gets whoa, I already did this. That takes configuration properties that you can pass into your auto starter, and the auto starter will create the right beans for you. So this is, for example, that what the Spring Data Neo4j boot starter does right now. It takes the connection parameters and sets up a bean that a session or a session factory bean that we can then use in Spring Data Neo4j. So I could, because there's this session or session factory bean, I could then say, just before we come to the Spring Data Neo4j example, because we can then say, if I do want to have it, I just write it here. I want to get this injected by the Spring framework, so I do not have to type my informations. And the default the default entity scanning will start at my application on my application level. So I can just rerun this application, and you will see that will store another disconnected graph in the database. Yeah, because I did not remove all the data. And then on this repository level, we will then have an interface. Whoa. That is defined. Oh, I have this zoom controls. Just a second. By the entity you want to persist and the type of the identifier. So this is pretty much everything you have to do to start with Spring Data Neo4j repositories. So this repository can then get injected. I just alter the session factory with a real Spring Data repository, like other Spring Data repositories also work. So Spring will then construct, or Spring Data will construct a bean of the person repository, then inject it into my application, so I can use it here in my it has, as I said, what I called quad methods on steroids. We have more predefined things we can work on. Just a second, I need to mute somebody, I think. No, I cannot mute. So the repositories by itself have these quad methods on steroid. But I told you that I will mention these so-called derived finder methods. The derived finder methods, as I said, derive cipher from your from the method name. So you will have then something like name and string. And it's an interface, so you do not have to write any implementation, but also the definition. And you can then just go ahead and use this method to find persons with a certain name. So we have a, it's gonna be, that's gonna hurt. So because I know, just returned one entity, I will get one into an error. So I just save another Gerrit, the Gerrit 2, and then say, please find Gerrit 2, and it will then generate the matching cipher for me and return person node. You can see this here as the log output. That person node is Java word again for me. Yeah. Yeah, I look at the clock. This is cool. But over a year ago, we got asked, oh yeah, there will be this Neo4j 4.0. It will have reactive support. It will have multiple databases. Can you support this in OGM? And we looked at the models that were used for modeling the mental model that were used for mapping the data. And we said, it's going to be tough work. So we got this, I would call it, within a company with a productive production product, we got this one in lifetime opportunity to create something new. And we called it Spring Data Neo4j. So yeah, we got this question, what would you do if you could create yet another object mapper from scratch? Yay. And so we threw ideas at it. And these are the more distilled versions of our ideas. We said, first of all, we do not want to mess around with other transport modes anymore. We just want to go full in bold because we work close for once. We work close with the driver team. And on the other hand, the bold protocol gives us all the information we need. And of course, we want to have this reactive support now. And we do want to have immutable mapping. Everybody has immutable mapping. Why don't we have immutable mapping besides JPA? And we wanted to reintroduce some concepts that were in Spring Data Neo4j before. So we wanted to put in the template again. But also a simple client that just does our data or driver interactions. We will see this in the picture. And we want to have Spring Boot integration better than we have now, because now you define everything for this Neo4j OGM session factory, all the configurations. We want to define all the connection properties like other Spring Data modules, but that was not the only need for us, but like a user wants to describe it. So we came up with this picture in our heads. So if we first focus on the bottom line, the first was more or less the first thing we saw that is needed is a Neo4j Java driver Spring Boot starter. So something that, like you've seen this before in the example or the demo, takes the application properties, but not this high-level defined application properties for a Spring Data module, but for the driver. So you can then have a configured driver instance configured by Spring Boot and Spring for you that you can get injected somewhere. So it will create this bean, and this is completely, first of all, completely unrelated to SDNOX. It's more like you can use it from today. It's compatible with, we have a release for the older 1.7 Java driver. And we have releases for the current 4.0 Java driver. You can just use this starter that is currently available under the org neo4j coordinates, and get a managed instance of your Java driver. But having this, we could then say, with our SDNOX boot starter, we focus on the bits we want to have people get configured. Like there are options for explicit reactive mode, so that we can skip a few parts of class path scanning and be just faster on startup. That has nothing to do with the driver. And on the other hand, we will also create with the Spring Boot starter or with Spring Data Neo4j RX in general, the right beans you need. So we have a Neo4j client that sits on top of the Java driver. That's our bare metal level of communication with the Java driver. So it gives us all the atomic methods we need to work with. Then we have the next abstraction level in Neo4j template. For a Neo4j template, you can imagine like a client. So the Neo4j template knows already about all the meta information that are on the domain objects. So it can then derive a general purpose mapping mechanism. So you can say, Neo4j template, here's my custom cipher statement. Please execute it and map it to, okay, the best example I have today is a person, to a person. And the Neo4j template, when it gets executed, will use the Neo4j client to then talk with the Java driver. And then in the end, the Spring Data repositories, like something like you've seen just in the SDN example, will generate the cipher methods for you, or take your custom cipher when you add it to your repository definitions. But that's just something we did not mention here. And we make sure that the repositories only talk with the template, and then the template is responsible. There are no fast paths to go directly to the driver in our architecture. So first of all, we eat our own dog food, but we wanted not to close this, but give you the ability to choose the abstraction level you need. I forgot the example for Neo4j client. A Neo4j client is something you put in custom cipher and can then say, you can then say, map this please to a person. And here I give you a mapping function. So a person gets constructed by, I don't know, you get a result set, taking the name field, taking the ID field, and then calling new person with those parameters. So a Neo4j client is not aware of your domain modeling. It can map every POJO you put in there with the right mapping function supplied by you. And the best on this rectangle you see there that's called SDNOX is that everything that runs in there is supports the Spring Data as the Spring transactions. So you can have this application side transactional annotations, and you can be sure that everything respects the transactional context it is working in. So a lot said. I have a last demo for this for SDNX. It looks about the same, but it's much more reactive. And yeah, I struggle when I say SDNX today, because we decided to move this project that also lives right now under the org neo4j coordinates to, again, like Swing Data neo4j already is, to the Swing Data team. Yeah, repository. So we develop it. We will develop it in the future also, but we make SDNX in the upcoming Swing Data version a replacement for the current Swing Data neo4j. This implies a few API changes, but yeah, we have a migration guide. It's very important for us to take the opportunity to make this move, that we do not have two so-called SDNs out there, but a successor of the classic SDN in place where it belongs. So as I promised, there is another demo for SDNX. It does not look much different than the first one. Besides that, that you can already see minor changes to the API. So a node entity is now a node because we want to describe nodes and not node entities, such things. But this is just the surface you see. We did want to have a surface that 75% feels like you were using the old library. So you do not have to do all the migration or a lot of migration work. But under the hood, we completely have rewritten everything. Swing Data neo4j is not connected to neo4j OGM. It is a standalone object mapper that just sits on the shoulders of Swing Data Commons library that supports us with their functionality for creating instances, all the immutable support and similar things. So we do not have to write our own object graph mapper from scratch. From our users and customers, we have barely seen people using OGM directly and are not working in a Spring ecosystem. This was another reason for us to say we go full in Spring. And we see also today there is no drop in adoption of Spring and Spring Boot application, Spring Boot framework. So this application looks about the same. As I said, we already have our person and person repository. I just wanted to find my person again. So we have here also just this one relationship. We have a person repository that is now, for the brevity, I just included the reactive example. That is now a reactive repository. It has, like we have seen this in the other example, the same methods, but so more or less the same methods, but the return types are now the project reactor reactive types. So instead, for example, of a list of a person or an optional of a person, I return flux or mono. So the mono is a reactive wrapper type that either returns nothing or one signal. So a signal is the data or a data block, if I have to translate this somehow. And the flux can have nothing or n amounts of signals until it completes. So with this, I have full control over the communication with a reactive connection. So if I want to, I don't have an example right at hand. If I want to throttle, for example, the data that's coming from the database, because I'm running in a memory limited environment, I can then, via my application, through the connection with the Neo4j Java driver to the database, say, please throttle the amount of data I get from you. I only can process, I don't know, 3 signals at a time. And I ask you for the next data when I'm done with this. But there are also other use cases for reactive. But reactive comes at a cost, and that's complexity. And that's complexity when you have to handle stacked traces, etc. But for this example, I just opt in for reactive that you can see this is reactive. I have created a short controller that returns the persons in the database. So the media type is something I need for Cur, that it really understands, or also for the Spring Web Flux project, that it produces a flow response and not everything at once. So for example, I can then just say, you can see the response. It does not come. We only have 6 persons, I think, in there or something. So you would see the response ad hoc, but we do not want to see this ad hoc. Let me just quit this application, and then we start our SDNX example. And then query for this endpoint. It's not running. That does not work in the IntelliJ console. I hope you can see this. No, it's not. I misconfigured something. Oh no, it's working. So yeah, it's 3 seconds. So you can see this. So now the persons get streamed to the client in a reactive way. So I could throttle this. So that's a brief example. I wanted to do more, but also I like to give introductions about graph databases. And if we had the opportunity, I think graph databases are even more interesting. Another interesting thing, you do not have to care about Spring Data, Neo4j, whatsoever, Neo4j OGM, but besides the Neo4j Java driver Spring Boot Starter, we created also a cypher-dsl. So you can define cipher statements, type safe, in Java. So, and you can, yeah, you have this reusable instances. We released it in parallel with the Spring Data SDNX releases. And then over the time extracted this already as an own module within the same project, but with its own namespace already. Today we made the move, so this is the reason why you are really getting the latest news. Today we made the move to extract the cypher-dsl as a very own project. And hopefully tomorrow is our first release of the very same module we had before, but with new coordinates to get used by you. To give you a short example, I just copied and pasted some code in there because I spoke about reusable bits. What are they and how does it look like to have this cypher-dsl? Unfortunately, I cannot use my mouse here. So we can create, of course, nodes that will then form this node pattern when they get rendered. We can formulate the whole relationships and then step into the where clauses in the middle of the lines. I just wanted to point there. I don't have anything to point right now. And then we can also define what we want to get returned. And I copied this from a test. You can see that they are. This is on the bottom. It's the cipher statement you get out there. The most important bit for you when I speak about SDNX or SDN6 then is that we use this cypher-dsl throughout the whole cipher generated string generated queries. So this is also a case where we eat our own dog food and say no, there are no short paths around this. We have to use the cypher-dsl to generate our very own statement queries. So as I said, if you're not interested in the other things, check the cypher-dsl out. And this is now the end of my talk. Bottom of the hour. If you're interested in SDN 6.0 and the further development, we published this morning a blog post about the future of SDNX, SDN 6.0, with references to other blog posts. So this is one of the main entry points. You can get information on this topic. I skipped all the repositories because now we have this move from SDNX to the original SDN repository of the cypher-dsl to another repository. So those links might be outdated at the end of the week. Most important is Neo4j downloads. If you did not have the chance to try it out, give it a try. The Aura instances where you can have your on-demand hosted instance. If you have any questions, reach out at the community side. Usually we check this at least once a day. So there's also a Spring Data section there. So thank you for your attendance. And I host kernel. Yeah, this computer thing, just a second.
Well done, well done.
Thank you very much, Gerrit. This is awesome. I'm so excited about the query-dsl or the cypher-dsl. I keep thinking about there was a time when I could use query-dsl with Neo4j, but that support has gotten broken somewhere. And it would be lovely to be able to create a cipher query, but somehow leverage Spring Data to retrieve it. Unless it's trivial with OGM. But yeah, there are interesting issues. I love Neo4j, but as I said, I started typing up the info for a bug I encountered. It might be my misunderstanding, but we'll see.
Yeah, we are looking forward to this. But yeah, for the cypher-dsl, they are also, we know at least from one company who's working directly with the cypher-dsl. So they migrated their whole queries to cypher-dsl. And the cypher-dsl gets used in our GraphQL plugin. So the GraphQL queries will then get transformed to Cypher queries via the cypher-dsl. So this was also one reason why we were driven to extract the Spring parts from cypher-dsl, so that we have a Java-only and dependency-free library.
Wonderful.
So
Cannot wait.
thank you, Gerrit, for a wonderful presentation of what we're doing over the last years. I think that the point came across very well at the moment, and I think Cornel already know that. Some of the other folks maybe as well. There are a huge number of combinations you can run on Spring Data and Neo4j at the moment. This is nice at first time, or if you look on it very superficial, but you can at the moment grow in every direction. You can grow horizontally and vertically and stack things together, and at some point you just keep losing track about things, and we want to provide a more simple but more powerful solution with the SDN 6 version coming up by the end of the year. And I think that came across very wonderful. And then starting up like today with extracting the first modules like the cypher-dsl gives us a whole new bunch of opportunity. I mean, you mentioned cypher-dsl support, Cornel. That's something we don't want to have directly in the Spring Data module, but that's something you can stack on it in a, I say in a vertical way. You can, we have ideas, or I have ideas how we can plug the cypher-dsl support from the cypher-dsl support in that side. And if we do this, you can then use the cypher-dsl, as you can already know, to fire up the Neo4j client or the templates and provide them with queries. So you can either pass strings to them, as you would write down just a Cypher string in a Java string, or you can pass them a compilable statement, which should give you all the possible freedom to craft your queries in a type-safe way. When we speak about it, I usually say both Gerrit and I have quite some experience in working in projects and consultancies, and there is no silver bullets in regards of data access. There are tons of situations where simple CRUD access is just fine to just define a node, or be it a JPA entity. I mean, there's a whole world of data out there. Relational data is, of course, valid database and great databases. And sometimes you just want to have some CRUD operations. Fair enough, define your entities or nodes and save them, and you're good to go. But as soon as you start working against the object graph mapper or the object relational mapper, then things are getting increasingly hard. So that's why we wanted to create holes in the abstraction on purpose, so that you don't have to force your way into the object mapper to execute a custom query, but there is an API or an SPI to get your query in and get stuff out. And I think that's a little bit missing in other object mappers. A carefully designed way to go into the thing and get stuff out.
Thank you very much, gentlemen. Are there any questions from our audience? Anybody can put their hand up. There's a little thing you can click on the bottom.
Are you sold or unsold on Zoom as a platform for broadcasting your talks now?
Should I say, oh, Teams is better because I never have used Teams?
No, I haven't used Zoom what do they call it, webinar. But it has support for different roles, and I know it makes it easy because you can choose who's panelists and who's the audience, and you won't have unfortunate interruptions. So the people who were spending 6,000 Rand for pizza can spend 400 Rand for Zoom webinar a month. So let's see.
What? No, that was a tongue-in-cheek. No, okay, we'll see. But yeah. But well done, Gerrit. That was really good. You have really good tenacity and stamina. Yes, that was a pretty
It's nice.
large amount that you covered in that period. But that's
yeah,
great.
I was asked to do this, so I could also certainly speak about SDNRX for 1.5 hours only. So
I actually work with the pivot.
Imagine.
I actually work with the Pivotal team and the Spring Starters, and they're so important to the developer community to actually get started on those different technologies. And there's so many of them. And you just kind of run them, and they have a Maven archetype if they do, and then you start with that. It's the connectivity, the integration between all of the different Spring Starters, which if you could help me with, you could just write something to connect all of the 50 or 60 that are out there right now. But yeah, no, I appreciate that. And graphing definitely seems to be the way that industry is moving for nearly everything. Just for plain old logging, just for plain old queries and databasing, it really seems to be much easier to have that relationship view than that select star from Bobby Table's nightmare that we've all grown up with.
Yes, the thing is that the reality is that relationship is something real, whereas in a relational database, it's computed.
Yeah.
And that's the penalty that you pay every time you access the relationship. Whereas if it's established, it's so much faster. And the reality is that the world is a graph, and we've been squeezing it into rows and columns
That is so true.
forever. And but I mean, working with a graph is still not the easiest thing around. You really have to plan carefully because you can easily land yourself in trouble. And there's a lot of ways to navigate the graph, and that's the big challenge. And I think I'm excited to dive in and see what cypher-dsl does and what you guys are planning forward.
Just a question for cypher-dsl. Are you going to look at with the GitHub letting people contribute to it? So PR requests open to the public. Can they get started in this? Can they assist in testing?
Of course. So we already did this with SDNRX in very early days. And within this SDNRX project were the cypher-dsl. And we got contributions from, for example, the company who is working with cypher-dsl right now. When it's called, so the naming is a little bit, okay, just get this straight. So there was a cypher-dsl until 2012. And it got not really developed. Then we created ours, thought, oh no, there's a clash in the naming. So we called our DSL the Open cypher-dsl because we also support the Open Cypher specs. And yeah, just today we decided to drop or to bring the former cypher-dsl module to a new level. And now it's called again cypher-dsl. And yes, you will find it on neo4j contrib /cypher-dsl. Maybe Michael has the link at hand.
Yes,
because Michael has just pushed the changes a few hours ago.
And we went actually through some length to keep both the contributions to the 10-year-old module and the new contribution we received on when it still was part of the SNX project. So we actually do value contributions very much, and we love to help people creating contributions. If someone wants to push something bigger or create a bigger feature, please ping us beforehand. We open up an issue, describe what you want to do or what you want to add, and we can work on this together. I mean, if you just want to change a typo or something like that, just do it, open a pull request, we have a look and merge it. When we receive a pull request in the hundreds of lines, that's kind of hard to review out of the blue, I'd say. So that's always better. And I mean, that goes, I guess, for every open source project to reach out beforehand. But please come with your ideas at us. The links are in the slides and also in the chat. Let's create something together.
Great.
Wonderful. Thank you, gentlemen. And we will.
Thank you again for the invite.
We will definitely speak again. I would love to get you back when there's some an update on 6.
Awesome.
And yes,
Certainly
thank
do.
you for offering your time and spending it with us. Thank you for joining us, everybody. And everybody be safe and be healthy and stay sane.
Yeah.
Thank you so much. You're going to make this recording available for us because I couldn't keep up.
Yes, I am.
Awesome.
The food was too tasty.
No, the information was too much.
Honestly, my wife was also in my room and brought me something to eat. So it's
I have to go now because I need to.
Bye bye, everybody.
Cheers, everyone.
Thank you.